This presentation is on Chapter 12, Perfectly Competitive Markets, Firms in Perfectly Competitive Markets. We're going to discuss what a perfectly competitive market is, how a firm can maximize profit in a perfectly competitive market, decide whether to produce or shut down in the short run, and if everyone can do it, you can't make money at it, and perfect competition and efficiency. The next few chapters, we are going to examine several different market structures, models of how firms in a market interact with buyers to sell their output, which are goods and services. The market structures we will examine are in decreasing order. So we're going to start with perfectly competitive and then monopolistic competitive markets, oligopolies, and monopolies. Each market structure will be applicable to different real-world markets, and will give us insight into how firms in certain types of markets behave. So this is a really good table, table 12.1, and it should be helpful for you. So you should take notes on this market. So if it's a perfectly competitive market, these are the characteristics. We're going to talk about the number of firms, the type of product, the ease of entry, and then give examples. In perfectly competitive, there are many firms selling an identical product. The ease of entry is high, which means it's easy to enter. And the example is growing wheat or growing apples. Agriculture is one of the main examples of a perfectly competitive marketplace. Then we go to monopolistic competition, which is the number of firms are many, but they're selling differentiated products. The ease of entry, so it's easy to enter. Clothing stores and restaurants. Oligopoly. So there are a few number of firms either selling identical or differentiated. The ease of entry, so it's not easy to enter this. Manufacturing of computers or automobiles. It's more difficult to enter this marketplace. And then a monopoly, there is only one firm selling a unique product. Entry is blocked. The example, you can't get mail from someone, first-class mail from anyone but the U.S. Postal Service. And you can't get water from anyone but the city. So these are examples of monopolies. We'll go on to talk about each of these structures differently. Today we're going to focus on perfect competition, or perfectly competitive markets. The first market structure we'll examine is a perfectly competitive market. There are many buyers and sellers selling identical products, and there are no barriers to enter for new firms to enter. Basically, you and I can start entering this market if we want to. The first and second conditions imply So the first and second conditions apply that a perfectly competitive market or firm is a price taker. So because there are many buyers and sellers and they're all selling identical products, they are unable to affect the market price. This is because they are tiny relative to the market and sell exactly the same product as everyone else. As you might already have guessed, perfectly competitive markets are relatively rare. These don't necessarily exist too much, but by definition, a perfectly competitive firm is too small to affect the market price. Agricultural markets, like the market for wheat, are often thought to be close to perfectly competitive. So suppose you're a wheat farmer. Whether you sell 6,000 or 15,000 bushels of wheat, you receive the same $4 per bushel. So as you can see, demand is a straight line. There are thousands of individual wheat farmers. They collectively supply the overall market and demand for wheat, which determines the price. $4 is market equilibrium. Individual farmers take this market price as his or her demand curve. So here is market equilibrium. That becomes the individual farmers. This is the market as a whole. This is individual farmers. So no matter what they sell, it's $4 per bushel. So how can a firm maximize their profit in a perfectly competitive marketplace? We assume that all firms try to maximize profit, including perfectly competitive ones. Recall that profit equals total revenue minus total cost. So revenue for a perfectly competitive firm is easy to analyze. The firm receives the same amount of money per every unit. So price equals average revenue, which also equals marginal revenue. That's because the per unit revenue doesn't change. So whether we sell 0 or 1 or 10 bushels, the market price is $4. Total revenue is the number of bushels times 4. Average revenue is always 4 because it's always 4. And marginal revenue, each additional one, is 4. So for a firm in a perfectly competitive market, price is equal to both marginal and average revenue. So profit maximization goal. So in this, we need profit is total revenue minus total cost. So here is the total cost, which includes our fixed and variable, as we talked about in the previous chapter. So at 6 bushels, the total revenue is $24, the total cost is 16.5, and the profit is $7.50. So profit maximization would be at 6 bushels. We can also calculate marginal revenue and marginal cost for the firm. It's $4. Marginal cost is here. So profit maximization is where marginal revenue is greater than marginal cost all the way until MR equals MC. Marginal revenue equals marginal cost, if that's possible. So as you can see here, total revenue, and this is the total revenue line, and this is the total cost line, and at 6 bushels, the spread is the biggest, and that is the biggest profit. It is generally easier to determine the profit maximization level on a graph. Marginal revenue is a constant and equal for the price of a perfectly competitive firm. The firm maximizes profit by choosing the level of output where marginal revenue is equal to marginal cost, or right here, 6. The rules that we have just developed for profit maximization are that number 1, profit maximizing level of output is where the difference between total revenue and total cost is the greatest, and the profit maximizing level of output is where MR, marginal revenue, equals marginal cost. However, these rules require the assumption of a perfect competition. They are true for every firm. Neither of these rules require assumption of perfect competition. Specifically for perfectly competitive firms, we can develop an additional rule, rule number 3. Price equals marginal revenue. So total maximization profit is where price equals marginal cost. Use a graph to show a firm's profit or loss. We know profit equals total revenue minus total cost, and total revenue is price times quantity. Dividing both sides by quantity, we obtain the following. Profit divided by quantity equals price times quantity divided by quantity minus total cost divided by quantity. Q's can cancel out in the first term, and the second is the average total cost. So we can write this as profit divided by quantity equals price minus average total cost. When multiplying both sides by Q, we get profit equals price minus average total cost times quantity. The right-hand side of the equation is of a rectangle, the height, P minus average total cost, and the length is Q. So how do we show this on a graph? It is very common error to believe that the firm should produce the level at Q1, but actually it should be produced here. But this does not maximize overall profit. We're looking to maximize overall profit. Reinterpreting marginal cost equals marginal revenue. We know that we should produce at a level of output where marginal cost equals marginal revenue. We've been calling this profit maximization level of output, but what if the firm doesn't make a profit? Or at this level or any other, what if the firm loses money? In this case, we would want to make the smallest losses possible. Sometimes our losses are unavoidable because we have such high fixed costs. This turns out where MC equals MR is still the correct rule to use. It is the loss minimizing instead of profit maximizing rule. So, a firm making a loss. The situation is even worse for a firm making a loss. Not only can it not make a profit, price is always lower than average total cost, so it must make a loss. The smallest amount of loss is where marginal cost equals marginal revenue. This is loss minimizing, instead of profit maximizing. Once we have determined the quantity where MC equals MR, we can immediately know whether the firm is making a profit, breaking even, or making a loss. If price is greater than average total cost, they're making a profit. If price is equal to average total cost, break even. And if price is less than average total cost, they have a loss. In fact, these statements hold true at every level of output. How do we decide? How does a firm decide if they should shut down? Suppose a firm in a perfectly competitive market is at a loss. It would like the price to be higher, but it is a price taker and cannot raise the price. This leaves two options: continue to produce or stop production and shut down temporarily. If the firm shuts down, it will need to pay its fixed costs. The firm needs to decide whether to incur only its fixed costs or to produce and incur some variable costs and obtain some revenue. The firm's fixed costs should be treated as what we call sunk costs, costs that have already been paid and cannot be recovered, because even if they haven't literally been paid yet, the firm is still obligated to pay them. Sunk costs are irrelevant for your decision-making purposes. In 2012, Chevy was facing intense criticism over the production of the Volt, its small electric gas hybrid cars. Critics pointed out that while Chevy sold the Volts for $40,000, the average cost of a Volt was $80,000. That means a loss every time. But average total costs included large sunk or fixed costs for research and development. Chevy's actually increased profit or decreased its loss by $15,000 for each Volt sold. Stopping production would have resulted in a larger loss than if the Volt has actually produced. Whether it should have invested initially in the research and development is debatable, but once it was done, Chevy would be foolish to stop production because sales were weaker than they had hoped. A firm's shutdown decision is based on its variable cost, not fixed cost. So, they should produce nothing only if price times quantity or total revenue is less than variable cost. Dividing both sides by Q, we attain price is less than average variable cost. So if price is less than average variable cost, that means that you're losing money for each variable cost. You should definitely not produce. If price is greater than average cost, then MC equals MR rules should guide production. They should produce the quantity where MC equals MR. For a perfectly competitive firm, this means they should produce when marginal cost equals price. The supply curve of a short run. Because price equals marginal revenue in a perfectly competitive firm, the firm will produce where price equals marginal cost. So the firm supplies output according to its marginal cost curve. The marginal cost curve is the supply curve for this individual firm. However, if the price is too low, i.e. below average variable cost, the firm will produce nothing. Individual wheat farmers take the price as given and choose their output according to the price. The collective actions of the individual farmers determine the market supply curve for wheat. So if everyone can do it, you can't make money at it. Entry and exit from the firms in the long run. This will explain how firms enter and exit perfectly competitive firms and earn zero economic profit in the long run. Sasha starts a small carrot farm, borrowing money from the bank and using some of her savings. The explicit costs are straightforward. Implicit include opportunity cost of her savings and her salary that she gives up to start the farm. So she has water, wages, fertilizer, electricity, and payments to the bank. Her implicit costs are a $30,000 salary and the opportunity cost of the $100,000 she has invested in the farm. Total cost of the farm, $125,000. She produces 10,000 boxes of carrots each year and sells them for $15 each. Her total revenue is $150,000. She has a profit of $25,000 per year, the $150 minus the $125 of total cost. Unfortunately for Sasha, the profit in the carrot making business will not last. Why not? Because there's nothing to differentiate carrots, and she's a price taker. Additional farms will enter the market attracted by profit. Some farms will switch from other produce to produce carrots if that's more profitable, and people will open up new farms. However, it happens, the number of firms in the market will increase, increasing supply and in turn lowering the price Sasha can receive for her output. So this is the market equilibrium at $15. This is Sasha's at $15. The price of the output is determined by the market on the left. Sasha makes an economic profit inside the green box. The new firms attract more supply, which drives down the price to $10. At $10, basically, Sasha's at a break even, or an economic profit of zero. This must be true. The price must be equal to average total cost, but since price equals marginal cost, that means all three must be equal. Price equals average total cost and marginal cost. If price is $10 per box and carrot farmers are breaking even, the demand for carrot falls, and the price falls to $7 per box. Sasha can no longer make a profit where she makes the smallest loss is producing 5,000 boxes. Discouraged by the losses, some firms will exit, driving the demand curve inward, right? And then driving the supply curve upward, which will then result in a rise of the price to the $10. So we're back to break even. The previous slides show how long-run equilibrium is achieved in a perfectly competitive market. Long-run competitive equilibrium is a situation in which the entry and exit in the firms have resulted in typically a firm breaking even. If firms are making an economic profit, additional firms will enter the market, driving down the price to break-even level. If firms are making an economic loss, firms will exit the market, driving up the price to break even. Since the long-run average total cost curve shows the lowest cost at which a firm is able to produce a given quantity of output in the long run, we expect price to be driven down to the typical firm's long-run average cost. This means, in the long run, the market will supply any demand by customers at a price equal to the minimum point of the average total cost curve. Hence, long-run supply curve is a horizontal at this price. In a perfectly competitive market, long-run price is completely determined by the forces of supply. A long-run supply curve shows that the relationship between long-run market price and the quantity supplied. The number of suppliers basically just adjusts to meet demand at the lowest possible price. And this is the long-run supply curve. It's a horizontal line. Increasing costs and decreasing industries. Industries where production process is infinitely replicable are models by which a horizontal supply curve. But what if this is not the case? If some factor of production cannot be replicated, additional firms may have higher cost of production. For example, if grapes only grow well in certain climates, then the cost to produce additional grapes may be higher for existing firms. On the other hand, sometimes additional firms might generate benefits from other firms in the market, leading additional firms to have a lower production cost. Cell phones require specialized processors. As more firms produce cell phones, economies of scale in the processor reduce the cell phone cost. When firms earn economic profits in a market, other firms have a strong economic incentive to enter the market. This is exactly what happened with iPhone apps. The first provider for Apple in mid-2008, providing a highly profitable in an instant, more than 25,000 apps were available to iTunes in a year. That's because there was low cost to enter the market, and it was basically very small. Anybody with programming skills could write an app and have it posted to the store. As a result of this enhanced competition, the ability to get rich quick with a killer app fades quickly. So, efficiencies in economies really refer to two separate but related concepts. One is productive efficiency. It is a situation in which a good or service can be produced at the lowest possible cost. Allocative efficiency is a state of the economy in which production represents consumers' preference. In particular, every good or service is produced up until the point where the last unit provides a marginal benefit to the consumer equal to the marginal cost of producing it. These are not the same thing. This is lowest possible cost. This is where marginal benefit, MB equals MC. We have shown in the long run that perfectly competitive markets are productively efficient, but they are allocative efficiently as well. The price of the good represents marginal benefit to the consumer from receiving the last unit of goods sold. Perfectly competitive markets produce up until the point where the price of the good equals the marginal cost of producing it. Therefore, the firms produce up to the point where the last unit provides a marginal benefit to consumers equal to marginal cost, or MB equals MC. Productive and allocative efficiencies are useful benchmarks against which to measure the actual performance of other markets. Common misconceptions to avoid. While a perfectly competitive firm faces a horizontal demand curve, the market demand curve is still normal or downward sloping. In this chapter, there are many supply curves described. The individual firm supply, the market short-run supply, and the market long-run. Don't confuse those. Remember that zero economic profit is an adequate level of profit to cover opportunity costs. It is not a bad outcome for a firm. The reason for shutting down in the short run and exiting a market in the long run are different. Price is less than average variable cost in the short run and less than average total cost in the long run. And that is the overview for perfectly competitive markets.